Okay, all right, we will start. So let me share screen. Now we are going to do, we have some questions that we have not finished from worksheet 23 last week. All right, so we're going to quickly finish worksheet 23, then we're going to start worksheet 24. Okay, those of you who said today is a bad day or boring day for you, really hope that you have a better time, tomorrow onwards. All right. So, but I hope you had fun during recess time talking to your friends about your holidays. If you did go for any holiday, if not, sometimes being in Singapore can be fun as well. If you go to places that you have not visited before. All right, so we are at worksheet 23. All right, we are going to finish up worksheet 23, the last few questions before we go on to worksheet 24 today. All right, let's start. Question 8C. Magnesium oxide is commonly used to line the walls of very hot blast furnace. So I told you blast furnace is a very high temperature place. We will not survive inside. All right. So it's 1800 degrees Celsius, as you can see down here. Okay, 1800 degrees Celsius. So the wall, all right, so this is the wall. Okay, I'm highlighting the wall. Okay, this is the outer layer. This wall is made of magnesium oxide. All right, so it's made of magnesium oxide. Okay, this is a formula for magnesium oxide. So what property of magnesium oxide makes it suitable for its use, and then explain. Okay, so since it is very high temperature inside, actually the reason why it's so high temperature inside is because we want to melt the rocks. You know those precious rocks that we dig from under the ground? All right, those are rocks, all right, or we say iron ore. This iron ore contains precious iron. All right, but the stone itself, the iron ore, is a mixture. So we need to extract, we need to take out iron metal from the iron ore, from the iron mixture. All right, so from the rock that we dig from under the ground, we are going to extract iron, which is so important to us because iron is used to make, a lot of things, forks and spoons. Your metal forks, metal spoons are made of iron. All right, your metal cupboards are made of iron. So the property that we are talking about here, right, is high melting point. So this is the property. So property can be many things. Property can mean melting point, boiling point, density, all right, whether it's a good conductor of electricity, whether it's a good conductor of heat, all right, all these are properties. Okay, now I need to explain. So to explain, right, this is the explaining part. Okay, so a large amount of energy, all right, is required to overcome the strong electrostatic forces of attraction between the magnesium ion and the oxide ion. So over here, if you look at the picture, the green color are the magnesium ions. They are smaller in size. The red color ones are the oxide ions. I don't call them oxygen ions. I call them oxygen atom, but once the atom is changed to ion, I change its name. So oxygen atom, oxide ion. So the red color are the oxide ions. All right. So one is Mg2 plus, one is O2 minus. One is, so in other words, you have a positive ion, you have a negative ion. This word electrostatic, all right, means a positive and a negative, they attract each other. So in this case, it's 2 plus and 2 minus. All right, so we are talking about positive ion. And negative ion. Okay, so as long as the positive and the negative, they attract each other. I call that attraction electrostatic forces of attraction. Just give me a minute to admit Sherman. Okay, and mark his attendance. All right, hi Sherman. Right, so we use the word electrostatic when it's positive ion attract negative ion. All right, so just like north pole of a magnet attracts south pole of a magnet, similarly positive ion attract negative ion. So right now these ions are closely packed. All right, that's why it's solid state. So right now what you see down here is the solid state. So let me write here magnesium oxide solid. All right, the S, small letter S, stands for solid. All All right. So if I want to melt melt, that means solid change to liquid is melt. Then I will have to, I will have to break these forces of attraction. But I don't use the word break. I use overcome. All right. So I need to overcome all these forces of attraction so that the positive ions and negative ions say bye-bye to each other and they separate out. All right, so that they become liquid where they slide past each other. So right now they are all very closely packed together, solid state. If I want to melt from solid state to liquid state, I need to give a lot of heat energy so that I can overcome these electrostatic forces of attraction between the positive ions and negative ions, and then so that the ions can separate out, all right, and then become a liquid and they slide over each other or slide past each other. So that is the reason why it's very difficult to melt magnesium oxide. You need a few thousand degrees Celsius. All right. So that is what we want. We want to melt the rocks inside the blast furnace, but I don't want to melt the building. I want the building to be still safe. All right. So I want the wall of the building to be made of magnesium oxide because magnesium oxide is very hard to melt. It has a high melting point, needs a high temperature to melt it from solid to liquid. Then my building, the wall of my building is very safe. Right, but yeah, I can melt the rocks that I did from under the ground. So in the blast furnace, they melt the rocks, all right, then they extract the iron from the molten rocks. All right, so let's move on. Now, normally I do not give you time to copy, but all these slides will be shared with you so that you can take down the answers. Okay, any questions so far for this 8C part 2? Okay, if not, then we move on. So we're talking about magnesium and oxide. Okay, so can everybody type into the chat? Magnesium is group what, period what? Everyone quickly. I'll just count down 5 seconds because I need to hurry y'all to give me the answers in the chat. Otherwise, we waste a lot of precious time. Can you give me magnesium group number, period number? All right, so give me in one line. Group what, comma, period what? All right, magnesium. Magnesium group what? Right, so magnesium group what? And period what? All right. I'm very happy that most of you remember that group number, you need Roman numbers. All right, you need the Roman numbers. You have to look at the top part, the way they write the group number. So you cannot write the 1, 2, or 3. So most of you know that it is in group 2, except you wrote the 2 wrongly. And most of you very good. It's group 2, period 3. So many of you did not get tricked by me. This is period 1. It's quite hard to, okay, right. Period 2. Oops. Never mind. Period 2. And then you have period 3. All right, so it is period 3, group 2. Oops, my 2 is wrong. Just so y'all don't write like that, and I myself write that way. So group 2. This is how you write the 2. All right, group 2, period 3. Okay, so this is a quick revision. All right, let me see somebody. Yeah, okay, good job, most of you. All right, you can see Javier, Yujie having perfect answer. If you gotten it right, but I didn't mention your name, don't be angry with me. Haresh also good job. Larissa, good job. Ais, just remember your 2 must write in the capital I and capital I. Group number, use Roman numbers. All right. Other than that, Ais did well. Harini, good job. Javier, good job. All right. So I have already, those who have shared your answers, thank you very much. All right, let's move on then to the next slide. Now here is draw the dot and cross diagram for magnesium oxide showing all the electrons. All right, so can you tell me if I want to draw electrons, I look at small number or big number? You know, from the periodic table, we have 2 numbers, right? I don't care which one is on top, which one is below. You don't memorize on top or below. You just memorize smaller number, bigger number. So if I want to know electrons, how many electrons? Do I look at the smaller number or bigger number? Can everybody type to the chat, please? Do I look at a smaller number? Like, do I look at 12 or 24 for magnesium? Smaller number or bigger number? Okay, Javier, Harini, Larissa, good job. Kiran, good job. Haresh, good job. All right, so most of you know that it is looking at the smaller number. You always learn small numbers first when you were in kindergarten. So remember proton, PEN, just write your pen, P plus, electron is minus. All right, then 12, you write 2 times. Right, then for the last one, you take big number minus small number. All right. Okay, you will have 12. Right, then for oxygen, I'm going to do the same. P plus, E minus, N. So pen, P, N, pen. So take the smaller number, 8, 8, and 6. 16 minus 8 equals to 8. All right, so then when I want to do electrons, I look at 12 electrons. Can everybody type into the chat, what is the electronic structure for magnesium atom? What is the electronic structure for magnesium atom? Everybody type in the chat, 5 seconds. 5. Electronic structure for magnesium atom. 4. 3. Please try. It's okay to get it wrong, but at least I would like you to try. What is the electronic structure or configuration of magnesium atom? All right, I have typed, let me type the question into the chat for everyone. Okay, can you type your, let me hang on, enter. All right, if you look at the chat, my question is there, what is the electronic structure or electronic configuration of magnesium atom? Can you type your answer into the chat? 5 seconds, 5, 4, 3, 2, 1. I only have 2 answers. Haresh and Harini, good job. Then the rest of you, you're eating dinner or are you in front of the laptop doing lesson with me or you're cheating? All right, so actually by right, I should insist that you turn on your camera, but I don't know, you are so shy. All right, but all I ask for is please don't waste your parents' money. Please pay attention. If you don't understand, please stop me or type into the chat. You don't understand, it is okay. I will help you. All right, but if you don't understand, please don't suffer in silence. Okay, Javier, thank you for telling me you don't understand. All right. So that's what I want. If you don't understand, type in the chat. I don't understand. So my question was, what is the electronic structure? So Javier, I have 12 electrons. All right. So how many electrons will be in the first shell? Javier, would you like to unmute yourself? Try. First shell can take in how many electrons? 2. Thank you. Then I'll put 2. Then either put comma or put full stop. Then what is the how many electrons in the second shell? Javier? Second shell can take maximum how many? 8, thank you. Now I have 2 electrons in first shell, 8 electrons in second shell. 2 plus 8 is 10. So I must have how many electrons in the third shell, Javier? Thank you. So your answer is out already, Javier. All right, you just what you don't understand what is the meaning of my question. So my question is, what is the electronic? What I'm not asking you to draw. What state the electronic structure? All right, state the electronic configuration 282. All right, then for oxygen, all right, you have 8 electrons. So you do the same 2 plus 2 electrons in first shell, 6 electrons in second shell. 2 plus 6 give you back 8. All right. So this is the electronic structure for oxygen atom. So all these are the atom. Okay, let me write all the atom in blue. Right, but these two are not stable. In order to be stable, is either you are, those stable one is either 2, 2, 8, and 2, 8, 8. These are the stable ones. All right, all the shells are full. Either it's 2, 2, 8, or 2, 8, 8. All right, so right now, both magnesium atom and oxygen atom, they are not stable. So how do I make them stable? Let me change the color to maybe purple. So in order to be stable, okay, maybe I think it's easier to, maybe I just change to dark green. Okay, so from atom, I want to change the ion. It's called ion already. So 282 will then become 28 because it will lose 2 electrons. All right, lose 2